it's going live. Hello everyone, I'm Lucas Demarchi with Full Gauge Controls USA, and we are live from Miami, Florida. First of all, I would like to thank you all for being here today at our first live webinar session. We're going to be performing a series of live training events over the next few weeks. I know we are all going through a tough time with a lot of uncertainties, and we all wonder how long will that take. Well, I read something today that said knowledge is key during times of chaos. In fact, I couldn't agree more with that. I strongly believe that those who, during their free time, seek for improving their skill sets and learn new technologies will eventually exit this crisis and lead the recovery of our industry. So the adoption of new technologies to become more efficient has always been key to minimize the impact of social and economic crisis. And the idea with this live webinar is to bring together our industry and share ideas and experience that can help each other out. So again, this is a live event. So the idea is to make it as interactive as possible. You can see there is a chat feature. I can see all your questions in real time, and I'll do my best to answer all your questions. So please feel free to raise any idea, suggestion, concern, or comments throughout the entire presentation. Today, we're going to be presenting mounting, wiring, and setup of a medium temp digital controller. But before we get started into that, I would like to share with you a little bit about Full Gauge, what we do, the markets we serve, and how we can help you to raise the bar of your next job. So let's get started. So here we are, Full Gauge Controls. Full Gauge has been in the market, as you probably know, we've been in the market since 1985. We are a leading manufacturer of electronic control technology for refrigeration, air conditioning, heating, and solar heating applications. Full Gauge currently makes over 1 million controllers a year and export throughout 40 different countries. To learn more about Full Gauge, I would highly recommend you to browse through fullgauge.usa. I'm actually gonna leave here our website where you can find more information about Full Gauge. We have some nice videos that can take you through a factory tour, for example. You can see our physical installations. You can see how we manufacture those controls. So I highly encourage you to jump on fullgauge.us and learn more about Full Gauge. So as far as solution, Full Gauge have temperature controllers that can be used for walk-in applications, reach-in, upright, chest, any bottle coolers, and any type of cooler or freezer equipment. In addition to that, Full Gauge also have a line of dedicated temperature and humidity controllers that are ideal for wine cellars, fruit ripening rooms, computer data centers, cigar humidors, and other applications that require precise temperature and humidity control. We also have a line of dedicated pressure-based controllers that goes from a very simple single-stage pressure-based control to the more advanced rack pressure-based control for refrigeration racking system. Electrical power, we have controllers that can control single, dual, or three-phase equipment for monitoring and protection. We also have a line of dedicated multi-stage temperature controllers that can be used in a variety of refrigeration as well as air conditioning applications. And lastly, but not least, we have a line of dedicated solar heating controllers. Some of the key applications for full gauge products will go from restaurants to hotels, hospitals, airports, logistics centers, distribution centers, factories, any site that that requires precise and reliable temperature control. So all the temperature sensitive applications could be served with the full gauge product line. And here we have a number of prestigious customers throughout the world who rely on full gauge for their temperature, humidity, pressure, and voltage data. So as far as company, full gauge is ISO 9001 and 14001 certified. That proves the commitment towards environmental friendly practices. That has always been a key driving factor for full gauge. And as far as product certification, our products are certified by UL, NSF, and CE for the European market. So we've all seen a transition in North America. We all noticed a transition from, we noticed that the industry is actually changing from mechanical controls over to digital electronic controls. And why is that transitioning happening? I would highlight three main topics for that. Digital controllers are more versatile. So with the controller we're going to be looking at today, it's a medium temp, very simple, straightforward, one relay, one sensor controller. That's a very versatile controller. You can use as a thermostat control, but also as a fan cycling control, as a code control, and a number of other applications. So versatility is definitely one of the key aspects for the digital control technology. Another thing is the precision. So digital controls are more accurate than the mechanical controls, which provides a more stable temperature control. In addition to that, you get huge energy saving only by switching from the mechanical over to microprocessor-based technology to control temperature. So that precision actually provides more energy saving. So those are the three main reasons why we've seen this transition over the last few years. So versatility, energy saving, and accuracy. Those would be the points that I would highlight for that transition. Now, the benefits of electronic controls. What the controls will benefit your customers? So, first of all, increase food safety with precise temperature control. Electronic controls works on a microprocessor. There is a microprocessor-based technology in there. So that provides better accuracy and more precision when we look at food safety. So in addition to that, to minimize product waste due to poor temperature control, we all see there are some very sensitive, temperature sensitive products. So if you go outside of that desired or that acceptable temperature range, you're risking to lose products. Ice cream is a good example of that. Ice cream, once it melts, it doesn't get back into deep quality. So it becomes a poor quality product due to poor temperature control. So by having a precise temperature control, you can actually extend shelf life for your products and maximize energy saving with better on and off cycles, with more efficient defrost and things like that. Another thing is the predictive report. So some controls have the capability of being connected to a computer. There, where you have the data logging capability, and you can see past recorded data, and you can better understand the performance of your refrigeration system, raising possibilities for predictive actions, which will eventually prevent equipment downtime. So those are the things, those are the points that you can upsell this technology to your customer. So I've personally been talking to a lot of contractors over the last couple of weeks, and we are all going through a very tough time. I mean, the number of service calls has gone down during the last couple of weeks, and some guys might have to change their structure. They might have to downsize personnel and things like that. So here becomes a good opportunity to upsell your projects. So whenever you're going to service an equipment, you can also upsell that project by switching, by retrofit existing mechanical controls over to digital electronic controls. That's an alternative to increase your average ticket price. And here are the reasons how you can upsell this technology to your customer. So I would like to talk a little bit about this partnership, Full Gauge and Renco. Before we get into the technical stuff, I would like to present this. So Full Gauge has partnered with Renco Robert Shaw for the North American market. So that's what is happening. Full Gauge and Robert Shaw have partnered for the aftermarket. So Robert Shaw Renco is the master distributor of Full Gauge products in North America. So this is a very good partnership. We've been working together since November last year. We got our products into the major wholesalers. So you guys will find Full Gauge products readily available at major wholesalers. So that's one thing that I would like to share with you, and I think will definitely help to bring more product availability into the market. Here is the new packaging we have. We have co-branded packaging with Renco for North American market, for the US market. So these are the two main controls we're going to be marketing in here. One is the MT512, which is ideal for cooling and heating applications. And when you're looking into the cooling application, OT medium temp refrigeration systems can be served with that controller. However, when you have the freezer applications, the low temp refrigeration system, you might want to go with the TC900E. That one provides you the capability of controlling your evap fan and your defrost cycle independently. So that allows you to run either electric or hot gas defrost with your refrigeration system. Today, we're going to be looking at the MT512, which is an ideal solution for medium temp refrigeration applications with off-cycle defrost, as well as some heating applications. Here is just like another look of the new packaging, and you will soon see those controllers available at your nearest wholesaler. So here we get started. Installation and configuration guidelines for a medium temp refrigeration application. So let's look at what are those medium temp refrigeration applications. So medium temp refrigeration applications can be reaching coolers, for example. Under counter, so that 512 goes well for reaching coolers. Under counters, during this presentation, you will see how to retrofit mechanical controls over to digital controls on those applications, as well as how to replace OEM controls using a full gauge Renko controller. So under counter, that's one medium temp application that will go well with the MT512. Prep tables, reaching, under counter, prep table, buffet line, cooling and heating on the cooling and heating side. So on the solid bar, you can install one 512, as well as you can install the 512 on the hot side of that buffet line. Bottle coolers. Even walk-in coolers can be serviced with this tiny, compact little controller. It's small in size, big in capabilities. So let us look at what we have. So the MT512 2HP, it's a dual voltage controller. So you can either power in 110 or 220. We also offer a version of 1224 volts, and the temperature range with those controllers goes from minus 58 degrees Fahrenheit all the way up to 221 degrees Fahrenheit. And again, it is ideal for reaching, upright, chest coolers, prep tables, walk-in coolers, and any type of medium temp refrigeration application that requires temperature control as well as off-cycle defrost, natural defrost. One thing that I would like to highlight in here that this 512 is ideal for, it's certified for R290 and R600 applications. So those flammable refrigerant applications are also a good application for the 512. So this becomes a really good replacement for OEM controls out there. Installation. Controller has the same cutout, the same dimension as the other controls. So it keeps the same footprint, the same cutout as the existing OEM controls. That's what I mean, that instead of going back to the OEM to order that replacement controller that will cost you a ton of money and you're gonna wait 2-3 weeks lead time in order to get that, you can walk to the counter and get an MT512 for all your cooler applications. So that's what I mean. You can replace mechanical controls, OEM controls, and you can use in a different variety of applications. And we're gonna be looking at how we do that. So it's a panel mounting controller. It's a panel mounting. You have the same cutout as any other controller out there. We also provide some mounting accessories. We have a mounting plate, a stainless steel mounting plate, and an enclosure. In fact, the enclosure is what I have in here today. I have this enclosure with my MT512 installed on it. Another option for mounting those controllers are in electrical panel. So a lot of guys like to mount a controller on electrical panel next to a contactor and a circuit breaker for walk-in applications. That's normally what I've seen, walk-in applications they mount on the electrical panel. So they can actually add a contactor when they have loads higher than 2 horsepower, because the 512, the MT512 provides you 2 horsepower relay output. That means you can hook up your compressors up to 2 horsepower direct into the controller terminal. There is no need for external relays or contactors. So let's revisit the basic refrigeration cycle and see where the controller sits into it. So the basic refrigeration cycle comprises of compressor, condenser, expansion device, and evaporator. In a medium temp application, the controller will be either controlling the compressor or the solenoid valve. And the defrost cycle is normally an off refrigeration cycle. So that means we run the compressor for 6 hours, 8 hours, and we stop that compressor for 20, melt the ice on the coil. So on the basic refrigeration cycle, on a medium temp applications, the controller will be either connected to the compressor or the solenoid valve. In that case, the evaporator fan will be connected either direct into the line so that the evaporator fan runs continuously, or we're gonna connect the evaporator fan together with the compressor. So the fan cycles on and off together with the compressor. Let us look now how to wire the controller direct to the compressor in that case. Again, in this application, the controller is basically controlling the compressor, and you have a temperature sensor on the air return. So based on the air return temperature, you have the compressor on and off. How do you connect to the compressor? That's what we're gonna look at in here. So as I mentioned, the 512, it's a dual voltage product. So you can actually power the 512 on the terminal 9 and 10 for 110, or terminal 9 and 11 for 220. One nice feature about this controller is that we have an independent circuit for the relays. So what that means, having an independent circuit for relays. Guys, I'm able, sorry, let me just go back a little bit. I'm able to see all your messages in here, and I will soon reply to all of that. And thank you very much for sharing your comments, your questions in here. Let me pick one in here, Terry. So here's a question from Terry. So those three, TC900, MT512, and MT514, are the models approved for use with R290 and R600? The answer is yes, Terry. They are approved for R290 and R600. In fact, we actually worked with UL to ensure that those controllers are not a source of ignition, and they can be used in any flammable refrigerant application. So yes, in addition to those three models, the MT444 is also certified for flammable refrigerant application. Thanks for your question, Terry. So let's go on in here. So what I was talking about was the independent relay for the independent relay circuit. That's what we have in here. So one of the reasons for this, one of the good things about having an independent relay circuit, it allows me to connect my controller, to power the controller in 110 and run a 230 compressor through it. Or for instance, run a 12 volt solenoid valve powering the controller in 110. But let us look at this particular case in here, where we have the compressor in 110 and the controller in 110. So what we're gonna have in here, how do you wire the controller in 110 to control a compressor 110? What we have in here, we have neutral and hot line going in terminal 9 and 10. That is feeding power to the controller. Now, what we gotta do, we gotta bring that hot line from terminal 10 into the terminal 16. That means we are energizing the relay circuit. So you are feeding power to the relay circuit so that can control the compressor in 110 volts. So this is what we have in here. We have, in fact, we have in this wiring diagram, we have neutral into terminal 10 and the hot on terminal 11. And that terminal on terminal 9, sorry. So neutral going into terminal 10 and hot going into terminal 9. And that hot line is also going into my terminal 16 to feed power to the relay circuit. So once the relay closes, that power comes back in through terminal 15 and feeds my compressor. So this is a very simple, very practical example on how to wire the controller in 110, controlling a 110 compressor. So now let's say we don't want to control the compressor directly. Let's say we want to control the expansion valve, the solenoid valve in that case. So what we have in here, we have the controller powered up in 110. Again, we have neutral going into terminal 10 and the hot line going into terminal 9. And that terminal 9 is also feeding power to my relay circuit on terminal 16. Once the relay closes, power comes back from terminal 15 and feeds my solenoid valve, which will be activated or deactivated. So that's how you wire this 512 in 110 volts. Let's say if we had to wire this 512 in 220, I would again bring the neutral on terminal 10. That doesn't matter. You can actually feed terminal 10 or the terminal 9. But in this case, we are actually feeding the neutral on terminal 9 and bringing the hot line on terminal 10. But if you want to power in 220, you're going to actually bring the hot on terminal 11. Terminal 11 is for 220. So would it be 9 and 11 for 220 volts. So here is a question that I get a lot. Where do I mount the controller sensor? So as you could see, the 512 had one relay output and one temperature sensor. So the temperature sensor says the temperature on the air return. That's the ideal position for the temperature sensor, on the air return of your evaporator. Why on the air return? Because that's the warmer spot of your cold chamber. So you want to place the sensor at the warmer spot so you ensure that the temperature is kept within the desired limits. So normally contractors and installers will place the sensor on the air return. So let us understand the display of the MT512. And that's one of the beauties about digital controls, is that you have an instant feedback on your controller about the current stage of the system. So for example, on the top of our screen in here, we have indication LED icons. We have one that indicates the cooling, whenever the cooling system is on or off. If the controller is set for heating, this controller has the capability of working under the heating mode. If the controller is set for heating, the heating icon would be lit in here. We also have a defrost indication LED. So whenever the controller enters defrost, you're gonna have this defrost indication LED lit. This is good when I've seen a lot of guys that get a call from their customer saying, "Hey, my unit is not keeping a good temperature. My cooler is too warm." And first question you have to answer, you have to ask your customer, is there a defrost LED icon in there? If the defrost LED icon is lit, that means the controller is performing the defrost cycle. and the temperature inside of the cooler will definitely be warmer. That's an indication. And here we have the 4 keys. So we have up and down key, the set key that you will always press to confirm the actions. And we also have this flat tag key. This is actually a patent technology for full gauge product where the most common settings of a controller is located. So this works like a shortcut for the most common settings of the application. Operation. So controllers works based on set point and differential. Set point is the cutout temperature, and the differential is the cut-in temperature. So if we set the controller for cooling, whenever the differential is reached, the compressor will go on and will try to bring the temperature down until it reaches the set point. When the temperature reaches the set point, the compressor will go off and temperature starts to rise again. Whenever it reaches the differential, brings the compressor back on. That's under the cooling mode. Under the heating mode, your set point is the upper temperature, is the cutout. Again, is the cutout temperature is going to be the warmer temperature. So for example, if you set to heating, the controller will cut in at the differential and the temperature will rise to the set point temperature, which is the cutout. So on the heating mode, the set point is on the temperature rise, and on the cooling mode, the set point is on the temperature fall. Here is a good example on how do we change the settings on those controllers. It's very easy. Simplicity is one of the key aspects for this full gauge product line. So I'm going to be showing you how to change the settings in any of our full gauge controllers. So first of all, what are you going to do? Here I have an MT512 with my mounting enclosure. And in order to access the controller settings, what we gotta do, we gotta push up and down keys simultaneously. So once you push up and down simultaneously, it takes to the function F01. When you are at the F01, you press set to confirm, and then you use the up or down keys to go through the code 123. So we are looking for the code 123, and that's the access code for all the control parameters. So once we enter 123, press set again to confirm, and here we are, function 1, 2, 3, and so forth. That's another differentiation with the full gauge product line. So all the functions are in a straightforward format. You have function 1, 2, 3, 4, 5, 6, 7. We don't do that menu and sub-menu where other controller manufacturers rely on. That makes just complicated to set up. You have to keep going back and forth and provides a poor experience, a poor navigation experience. With our table-based programming, it provides you easy programming, and having the controllers, the functions in a numerical order allows you to easily identify which function has to be changed. So again, for changing the settings, we push up and down simultaneously, functions F01, set, and we use the up or down keys to navigate to the code 123. Once we are there, set, and we can change any of the controller functions. So let's say we want to change F02. Here is my set point, my cutout temperature. Let's bring that up to 90. Because here I want to show you one thing. I've got my compressor indication LED on, right? My compressor here, there is this indication LED on. Now I'm going to switch to 90. Here you go. My compressor just went off because my temperature, my display temperature is within that set point condition. So once it goes back, you're gonna see what's the temperature being read at the controller. Here we go, and we got 85 degrees. So you see, my compressor just went off. So that's how you change the settings on any of the full gauge controllers, just by pushing up and down simultaneously and entering the code 123. Now, operation. We understand that this controller has the capability of controlling cooling and heating. How do you set that? Function F07. When you access your controller by pushing up and down, we have the functions. We go on functions F07. Here we go. We have function F07. So if F07 is set to 0, the controller works on the refrigeration mode. If you change this to 1, the controller works based on the heating mode. Controller comes preset to refrigeration, and in this case we're gonna leave in refrigeration. So the first thing you have to do is to set what's your cut in and cut out temperature, what's your set point and differential. So the set point is the cut out temperature. Let's say we want to set the controller to 32 degrees and have a differential of 4 degrees. So that means the controller works from 32 to 36 degrees. How are we going to set that? So F06 is my differential. Here, I'm going to set this to 4. So F06 to 4 will provide 4 degrees differential on my cooling system. The controller, once you're working on the cooling mode, the MT512 provides you an off-cycle defrost capability. What's the off-cycle defrost means? Means that the compressor, the system will work under refrigeration for a configurable time. That can be an interval of 4, 6, 8, 12 hours, depending on the application. And the system will stop for 20, 30, or 40 minutes at a user-definable interval to perform that defrost cycle. So that means with my MT512, I can replace the thermostat as well as the defrost timer. So you're replacing thermostat, defrost timer, and also the thermometer. Why not to replace the thermometer since I have a nice big digital readout in here? So with 1.512, I can actually replace the thermostat, defrost timer, and thermometer, 3 to 1. And here are some of the characteristics about our off-cycle defrost option. You can adjust up to from 0 to 999 minutes. That means a 16 hours interval. So again, you can adjust from 4, 6, 8 hours all the way up to 16 hours. And you can also disable this defrost function. Some applications might not require defrost. So the defrost function can be disabled. And we're gonna see in the next slide, what are the defrost parameters. So first of all, first defrost parameter we're gonna be looking at, F010. That's the refrigeration time, is the defrost interval. So let's say we set this to 240 minutes. That means I will have one defrost cycle every 4 hours. If I set F10 to 360, I will have one defrost cycle every 6 hours. Another relevant defrost parameter is the F11. F11 is the defrost duration. And this one you can set to 0, which will disable the defrost function, or you can set all the way up to 999 minutes. The average defrost duration, what I mostly see as far as defrost duration on the medium temp refrigeration unit, goes from 20 to 40 minutes. That's the normal, what I mostly see out there in the field. So again, functions we would be changing: F02, set point, F06, differential. Those are my cut-in, cut-out temperatures. And F10 and F11 for the defrost duration and defrost interval. For most medium temp applications, only those 4 settings have to be changed. But now we're going to be looking at other parameters that can be changed to increase efficiency of refrigeration system. Before we move into that, I'm just going to show one nice comment we had in here from HVAC Tools. Hey, thanks for joining our live today. It's a pleasure to have you in here. And here is a really good comment and a really good tip that the FG Finder app has all the product manuals, easy access. So that's a free to download app that you can download on your Android or iOS phone or Windows phone. I don't know if anybody has a Windows phone anymore, but Android and iPhone, you're good to go. You go on your live store and you can download the FG Finder app for all the product manuals, application selection. You can actually search for products based on the part number, application, or segment. In addition to that, you can see videos, you can see where to buy. You have really nice features in there. So please go ahead and download FEG Finder on your App Store. So what are the other defrost parameters we have in here? So the other defrost parameter is F12, initial state when powering the instrument on. What that means that I can set the controller to start on refrigeration or start on defrost cycle. Why would I have the controller to start on defrost cycle? Does anyone know why we have that option? Here's one thing. Let's suppose we set this. So let's say we suppose have the system running. Let's say we have 6 hours refrigeration and 30 minutes defrost. Let's suppose we have that set up: 6 hours refrigeration and 30 minutes defrost duration. So after 4 hours of refrigeration, we have a power failure. Whenever power comes back on, if the refrigeration is set to start, if the controller is set to start on refrigeration, when the power comes back on, that 6 hour cycle will start from beginning. But we had 4 hours refrigeration before that. So now we're gonna have a total of 10 hours refrigeration, which might block the evaporator in that case. So that's the reason why sometimes you're gonna set the controller to start under defrost. So let's say we had 4 hours of refrigeration, power failure. Whenever power comes back on, the controller performs a defrost, the system performs a defrost, ensuring that the coil is free of ice, is good to go, and we can have our normal refrigeration cycle after that. So that's the purpose of that F12, initial state when powering the instrument on. Any questions about that? Please feel free to ask any questions. Lock temperature lock temperature indication during defrost, yes or no? So this allows you to lock the last temperature reading during your defrost cycle. And this actually prevents those false service calls. Sometimes you get a call from your, like we spoke before, customer calls in saying, hey, my cooler is not working, my temperature is too warm, and the system is under defrost. So by locking the last temperature reading before defrost, you can actually prevent those false defrost, false service calls. and additional time to the end of the first cycle. This is a good feature to desynchronize defrost cycles when you have multiple pieces of equipment. So let's say we have 5 coolers in one installation. We don't want those coolers to enter defrost at the same time. Let's say if we set the coolers for 6 hours refrigeration and 30 minutes defrost, and they all start together after 6 minutes, let's say we have 6 hours refrigeration, 30 minutes defrost, 5 coolers. Coolers are running fine. Whenever power failure happens, all the coolers will come back on at the same time and will perform the 6 hours and will enter defrost at the same time. And that will create an electricity peak. We want to avoid that. And in order to avoid that, you can set individual times. You can set different times on FC15 for every piece of equipment. So that way, your next defrost cycles won't be synchronized. But those are the defrost functions available with the 512. However, the 2 most common ones, the ones that really needs to be changed, are F10 and F11. Those are the most critical defrost functions. The other 3 functions will actually provide you a better performance. We will improve the performance of your refrigeration system and will will definitely save electricity. Let us look at the safety functions. What are the safety functions loaded with the 512? You have a minimum and set point threshold. So the purpose of that is to prevent end users to change the set point to a crazy condition. Let's put it this way. For example, I have my system working from 32 to 36. Sometimes customers, they don't know that cooler cannot be a freezer, and they want to set that temperature down to 10 degrees. What will happen? My compressor will run continuously. I will never reach to that 10 degrees with a cooler, and I'll get a failure. So in order to prevent those failures, you can actually set a minimum and maximum set point threshold. So the end users will not be able to go above or below those settings. That's for safety. So if you're setting your system from 32 to 36, you might want to set F04 to 28 or 30 and F05 to 40, 44. So that way, end users will not be able to tamper with the controller outside this range. Another safety functions loaded with the MT512 are minimum output on time and minimum output off time, F08 and F09. Why are those minimum output on time and minimum output off time? Those functions serve to prevent short cycles on the compressor. For example, some applications you're going to have a very narrow set point and differential. Let's say we have the set point as 32 degrees and my differential of 2 degrees. So the system will cut out at 32 and will cut in at 34. That's a very narrow set point and differential. So it's likely that my compressor will be going on and off constantly. In order to avoid that constant switch, you can actually set a minimum output on time and off time. So regardless of the temperature that it reaches, it will first respect the time. Again, to prevent compressor short cycles. And instrument powering on delay. What's the purpose of this feature? Again, when you have a power failure. So let's say we have 5 pieces of equipment in one site. We have a power failure. If each controller are set with a different power on delay, each equipment will go on at different times and will prevent that electricity peak. So F14 is good when you have multiple pieces of equipment in one site. And the last functions we're going to be looking at today are F16, which is the compressor situation with damaged sensor. So let's say, for instance, if your sensor fails, you have the option of the unit to continue working. So if your sensor fails and you have the, you can actually set the compressor to keep running. If you set F16 to 1, compressor will run continuously in case of sensor failure. Or if you set to 2, compressor will cycle between time on and time off. And those times are set on the F17 and F18 parameters. So that will allow you to set, let's say, if my sensor fails, I might want my unit to run 10 minutes on and 5 minutes off. That way I can have cooling while the sensor is being replaced. Well, I said that those would be the last two. However, we do have 2 more features, and those are the last 2 features, safety functions we have. So F20 allows you function blocking time. So you can actually lock the keys, preventing unwanted setting change. That is good for, let's say you want to, you set the controller and you know that there is a site where people constantly tamper with the control. So you don't want to let any users tampering with the control because they might mess up with the installation. So what you can do, you can actually lock the controller keys. In addition to that, you can provide the option of a partial lock, which only the set point is allowed to be changed. So you enable users only to change the set point, not the other parameters. And lastly, F21. That's turn on and turn off of the control function. So that allows you to turn the control into a simple thermometer. So let's say you don't want to use the control functions, you just set the F21 to off for maintenance, for example, or if you need to perform anything, instead of powering off the unit, you actually have the possibility to disable the relay output. So again, let's revisit this controller, MET512. Good for medium and high temp applications. It's a dual voltage controller, 110 or 230. Has got 2 horsepower relay output, 1 temperature sensor, built-in timer for off-cycle defrost, IP65, which is water protection. The display it's waterproof. Programming can be through the EasyProg. I'm going to actually show you a programming device we have that is compatible with the 512 as well as with the other controls. And again, 512 is good to replace any medium temp OEM control that requires off-cycle air defrost. And when you're replacing mechanical controls, it can actually replace the thermostat plus the defrost timer and the thermometer, of course, since you're going to have a digital readout. Applications, again, any medium temp and heating systems. So EasyProg, just before we end it in here, the EasyProg, it's a programming device. It allows you to host up to 9 independent setting options. So let's say I can have 1 programming for my upright cooler, 1 programming for my chest freezer, 1 programming for the walk-in freezer, 1 programming for my wine cellar, 1 programming for the heating buffet. So you can have up to 9 independent setting options uploaded to the key. That way you don't have to manually change the settings of a controller. So by having 1 512 and 1 TC900 on your truck, you can service 99% of the refrigeration applications out there And with the Easy Prog on your truck, it's going to make your life way easier, as you don't have to manually change controller. You can actually create your programmings on your computer back home on your office, and whenever you go to the job site, you just plug the key into the side USB of the controller and download settings to that controller. We also have an option for the MT512 with remote monitoring and control. So we have a proprietary solution called Setpoint software. That's the name of the software, which allows you two-way communication between the controllers and computer or cell phone, which allows you to change the control settings, retrieve historical data, or if anything goes wrong, the software sends out alarm message so you can be alert before the problem happens. And here is the FG Finder. I invite you all to download this FG Finder app in here. And I have a very special guest with us today that I would like to bring live. Let me bring him live in here, and we're gonna chat a little bit.
Hey, Lucas.
Hey, Peter. How are you? How's everything with you?
I'm doing great. Thank you. Thank you for allowing me to join you this evening, you and your audience. Thank you. It was very good.
Thank you very much for being with us. Are you good? Where are you now? Are you at your home?
I am residing right now coming to you from Fairhope, Alabama.
Wow, that's good. That's good. Yeah, I've been working from home for the last 2 weeks. You probably thought that we were live from Fullgate Studios in Florida, but we are actually live from my home here in Florida.
Yes.
We've been locked down for 2 weeks now, but we gotta continue pushing, and this will soon be over, and whoever takes the lead now will soon be over this crisis. So Peter, while I have you in here, can you please tell us a little bit about yourself, your background?
Sure.
How long have you been in the refrigeration HVAC sector?
Well, good. Good evening, everyone. Hope you all are safe and minding your P's and Q's. My name is Peter Greisinger. I am the Director of Key Accounts for Robert Shaw. I've been in the HVAC and refrigeration industry now for more than 20 years. Just a quick note on our company, some history. Robert Shaw began in 1899. That makes us 120 years old. Soon after, we established 3 strong brand names. The first being Robert Shaw, of course, in 1900. Then followed Renco brand, which was 1913. And then, of course, Paragon in 1927. All of those are living under the umbrella of Robert Shaw.
Wow, that's impressive. 120 years old. You guys went through a lot, huh? You can probably share some of that experience with us, and it's really good to be working with you all. And Peter, how do you see this partnership between Full Gauge and Robert Shaw?
Yeah, so the brands I just spoke about, Full Gauge will be aligning itself under the Renco brand name of Robert Shaw. We proudly partnered with Full Gauge to complete our refrigeration control offering. So from the simple mechanical controls, the ETC controls, O controls, and now with Full Gauge being the industry's leading refrigeration controls. So we're excited about that. Perfect partnership.
Wow, that's wonderful. That's really good to hear. And for those who are watching and are wondering where they can find Full Gauge products, would you be able to highlight these to us?
Yeah, so in the US, you can find these products. You can get access to the products at any local stocking Robert Shaw distributor is the best way to do that. Just walk in and ask. Wonderful.
And in case there is no So you're saying that products are available at most wholesalers across the country.
Well, yeah.
And in case the local store doesn't have, is there anything they can do in order to have access to the product?
So that's a good point you bring up. So as you begin a partnership, it does take some time to get product into the field. So it is accessible to the stocking distributors. All of them have access to the product. There's some that are already bringing it in and stocking it. You're more than welcome to go to the website, Robert Shaw, probably the easiest way to do it. Go to robertshaw.com. On the very top of the page, you can click on contact us, and you'll see the website there, or the email address that you see up on your screen, the HVAC customer service at robertshaw.com. Simply send in your contact information. Where are you located? And then we'll in turn respond with either the representative that is in that market. We have representatives covering the entire US that can guide you to distribution, of course, of your choice, and then help you process training if you need to get more product knowledge and training on the full gauge product line, where to purchase it and where it's available.
Wonderful. Hey, Peter, thank you very much for taking the time to join our call today, our live webinar. And as I mentioned from the beginning, we're going to have a series of live training events. So next week, we're going to be talking about low temp controllers for freezer applications.
Perfect.
So controllers that can feature electric or hot gas defrost. And from there, we will be introducing other innovative products, more advanced products that can really help contractors to improve what they're currently doing and move to the next level. So thank you very much for joining us. And I would like to thank you all for connecting to our live today. And please stay tuned for the next events. We're going to be sharing through our social media, through our mailing. And please go on our website, on Full Gauge, on Robert Shaw website, sign up for our newsletter. Like our social media, we both have Facebook, we have a strong social media presence. So please follow our social media page and stay tuned to, there is a lot more to come. So before we end in here, I just want to share one nice phrase. And I think it makes sense for these times we're living. So I saw today that there's the word fear. Fear has actually two meanings. One is forget everything and run. And the other one is face everything and rise. So I just would like to leave you all with this to think about, and I'm sure we're gonna be soon over this crisis, and we're gonna be continue to change our industry. Thank you all very much for being here.
Thank you, Lucas.
Thank you, everyone. Thanks for the audience, and stay tuned. Thanks. Bye, everyone.